All right. Now, overview of the TCP network, TCP/IP networking model. Let's talk about the TCP/IP networking model. Okay. The TCP first of all. Okay. There's two main protocols that work at this layer. Okay. TCP, which is considered a connection oriented. All right. Why is it called that? Because it's due to the three-way handshake. And what do I mean by the three-way handshake? Okay. The three-way handshake means say, hey, I want to send you a message. Okay. I got your message. Let me let you know that I got your message. Then you're going to send a reply. Once that three-way type of communication occurs, or handshake as they call it, then data can be sent. Okay, data can be sent. Also, you can call it a reliable protocol because it does error checking as well. All right. The transport layer provides services to the application layer protocols that reside what? One layer higher in the TCP/IP model. Don't get confused. I'm not talking about the OSI. You're saying, well, wait a minute, Elias, what do you mean the transport layer is one layer on top? No. We're talking about the TCP/IP model, right? Above the TCP/IP is the application, okay? Is the application layer. So those protocols that reside on the higher layer is in the TCP/IP model. I'm repeating myself big time because I want to drill that down. Now, the error checking is built in, all right? The protocols that it uses, all right, they're called acknowledgements or ACKs, and negative acknowledgements, which are NACKs, okay? Now, there's new terms that they use. There's new terms. I'll just name them right now, but we'll talk about it a little bit deeper later, all right, which they're called adjacent layer interaction, okay, and same layer interaction, but we'll talk about that later. What I want to talk about right now is how the HTTP overview and the HTTP protocol mechanism work. Okay, that's what I want to talk about right now. Meaning, when you want to get a web page onto your computer, your server, whatever it is, your phone, whatever device. All right, the first step is in the header, okay, it sends like a get message. It says, hey, I want to go to index.htm or home.htm, whatever that main page of that website, like yahoo.com or google.com or cisco.com or whatever it is, all those have an index.htm. We know this. So the first thing that happens in the header, in the HTTP header, is that get message. The second step to that is the reply, which in the HTTP header you get okay, and then it sends the data that says here's my home HTML. And then the other step, which is good, you can say step 3, 4, 5, 6 is I'm going to send you more information. Okay, so that's how that works. Okay, that's how that works. So when you click, all right, that you make your default home page, and you say, hey, I want to go to Google always because that's your home page, or you're using whatever browser that you use or home page that you want. That's what it's saying, and it's using that TCP, right, within the HTTP, because remember, HTTP resides in the application layer, but you're using TCP to make sure, since it's connection oriented, you want to make sure that it goes to the correct place. All right, that's what it does with that three-way handshake. So everything there is in the header. So that's this, okay? Because remember, take a look at it right here. Even in the new layer, it's the same thing. You got your transport and then the application. Transport, application. Okay? All right. So got that out the way. No big deal. The TCP/IP transport layer. I already told you about its error recovery. Now, I'll give you some basics on that. All right? The error recovery basics. Those are the ACKs and those are the NACKs. I told you already. Error recovery is built in. So you don't have to be concerned with it. You'll know. You'll get some sort of error message that you couldn't get to the web page, server not found, whatever the case may be, maybe a DNS issue, but that's TCP. It has that built in. The new statements are the same layer and adjacent layer interaction. Same layer and adjacent layer interaction. just some new information. What does that mean? What does that mean? Same computer that work together, similar to that function in the same layer. They interact with one another. So if they have an issue, they can relate into the same layer and fix it. Okay. The other one, adjacent layer interaction, okay, means that they're not on the same layer. All right. That it needs information from the lower layer to go up to the upper layer and then fix the problem. That's all that is. Just new terminology. Not a big deal. All right. Now, the TCP/IP network layer, internet protocols, and the postal service. Now, I can give you the analogy. What does that mean? When you're going to write a letter, and this is exactly what they're going to tell you in there, and it's been in every networking book from here to Kingdom Come, okay? When you write a letter, you put a stamp on it. You put this is coming, this is going to, and it's from, or is it vice versa? Well, whatever. You put the send, you put the destination and the source, where it came from and where it's going to. And you put a stamp, and you write your little letter, you put it in, you close it, and you put it in a mailbox. All right, then comes the mail person, picks it up, takes it to the post office. If is within, let's say, the same state, not the same state, the same city, it'll get there very quick, right? It'll go straight to the house that it needs to go to. So they can separate it fairly quickly. If it's going to another state or country, then the post office has to send it to another post office. What does that sound like to you? So they're saying, okay, wait a minute. That sounds something similar to IP routing basics, doesn't it? I know I skipped that one, but we'll come back to this one in a second. Okay? If you're trying to get to a network, and I got a lab for that, I think. There we go. All right. I think that's big enough. I think everyone can see that. All right. And let me put it a little bit more this way, because I'm going to be to one side of it right there. All right. If it's going within the same city, that's fine. IP routing basics has been the same thing from the get-go. Number one, this is only one network. But if we had multiple routers, that means each device has to have a unique IP address. Okay? Not all devices have the same IP address. Now I know what you're going to say, last, but doesn't that change in IPv6? Yes, it does. With the Anycast addresses, right? They're the same IP address that you can put on all the devices. But that's a different story. We're talking about IPv4. Okay? So for routing basics, making that analogy with the letter, since this is the same city, I just want to get to something on the other side. I'm going to go ahead and put my information. All right. I'm going to have the right IP address, which I have right here, right, in the desktop. I have my IP address. I have my subnet mask, and I have my gateway, my post office. Where do I need to go to in order for me to send this information? All right. So that has that information. It sends it. It goes through the switch to the router. But there's something in IPv4 which now we don't have in IPv6. And what is that? That's right, ARP. We don't have ARP anymore. Okay? So we have the ARP protocol saying, oh, wait a minute. That only happens once. So what happens? The router says, hey, you want my MAC address. Oh, my friend. You want my MAC address. No problem. Let me send you the MAC address, which completes the packet, and then it sends it out. Once it gets complete, then it goes into a router. Routers, okay, what do? They build a routing table. And what do they do with that routing table? They look at it and they say, oh, you want to go to this network. Well, all you got to do is go out this exit interface, and it could be that it's another LAN, because let's say this is a VLAN. This is VLAN 1, 192.168.1.0. You may have a 192.168.2.0, which is a VLAN 2. So it'll router right back into VLAN 2. It's within the same whatever, same network or same infrastructure. But it could be that it's going to somewhere totally separate, like the internet. Then it's got to send it to another router that's understanding, well, hey, listen, I got this address, but I really don't know where this is at. So let me send it to this router. That router may know where it's at. I'm going to send it out this interface. Then a router out on the internet takes that address and says, yes, I know where that needs to go. Let me send it to a correct location. That's where routers get involved. That's why routing tables are very important. And just to let you know, right now, routing tables need to be kept small. And we'll talk about summarization and all that later on in the course. But it still uses the TCP/IP link layer plus the physical layer. Why do I say that? Because it needs to understand that, hey, okay, I'm using its frames, but I still need to send it through a link, a physical layer, which is the cabling, okay, which is the cabling, all right? So the TCP/IP link layer provides services to who? The layer above the model. When hosts or routers are processing information or to choose the where it's going to send the packet to another router or host, okay? That host on that router uses that link layer. It will use that link layer, okay? Details to send that packet to the next host or router, okay, is what I just told you. It will look at its routing table. But what do switches have? Switches have a MAC address table. I may not need to go anywhere else. There may be another computer right here in my same VLAN. It doesn't need to go all the way to the gateway. The switch learns IP addresses too. So, or I'm sorry, MAC addresses. I'm rephrase, MAC addresses. So it'll recognize that MAC address because it's learning source addresses. It says, hey, wait a minute. This is my same LAN. Let me send it back down. It may not even get to your gateway. So it all depends. It's got to use that data link layer plus your physical layer because it's got to go through some sort of medium. It has to go through some sort of, whether it's wireless, whether it's fiber, whether it's, UTP cabling. It's got to go through some sort of medium, okay? All right. So let's go back to slideshow view. Okay. So that's what I wanted you to understand about this, okay? The next thing is, we're talking about that, right? Yeah, okay. Now, Internet Protocol addressing basics, okay? Internet Protocol addressing basics. When we talk about addressing, it means you need to choose, okay? Let me take out the packet tracer again because I don't want to confuse you just with verbiage. And let's do a new one just real quick. I'll say yes. Packet tracer always says yes to everything. I'm going to take out let's say a 2811, which is all the way here at the end. 2811. All right. Let's just do 3 routers real quick. Just connect them together. I'll move them to one side so you can see what I'm doing. I'll move them right there. Okay. And I'm just going to connect them. Use the lightning bolt to connect them. I'm just going to cheat. Okay. All right. And I'm just going to put a label. We're not going to configure anything. I just want to show you what I mean. 10.1.1.4 CIDR 30 and then 10.1.1.8 CIDR 30. Okay. Let's just leave it like that. Let's bring this puppy to the middle. Whoa. Okay. And let's zoom into it. Okay, right here. Okay, so when it talks about addressing, what it's saying is when you're creating your scheme, all right, you got to make sure that it's going to be enough. It's going to be enough, and you follow a sequence. Even though the routing protocols that we use do support what's called non-contiguous networks, meaning I can have a class A, I can have a class B for my LAN, I can have a class C somewhere else. It'll support that. But try and see if your configures. Normally a router means that this would be, let's say, Florida, New York, California, whatever. All right. And then within each router, that may be an edge router. Then you'll have other routers and other switches nearby. You need to create a good scheme, all right, before the design part of it has to be set before you do it. Because like I said in the beginning of the section, people have run out of, not public addresses, they've run out of private addresses. That should not be happening. All right. You need to think towards the future that, hey, this company is going to grow. I want to use an addressing scheme that's going to support the network. All right, but that's what they're talking about. They're not on the same subnet. This is a network. That's a network. All right, and we'll talk about devices in a second. All right, and down here will be a different network as well. Remember, each port on a router is its own network. So you got to develop a scheme, and that's what they mean by that. That's what they mean. Now, one thing that I didn't touch upon, all right, real quick, and that's, let me go to slideshow view again. All right, and I want to show you, yes, you see, yeah, okay, the link layer, we talked about that. Compare, okay, now we're going to go to the images. All right, this is our OSI. Application presentation, or all people seem to need either data processing or Domino's Pizza, and then data processing or, oh my God, all people seem to need Domino's Pizza. Yeah, Domino's Pizza. Okay, so this is your OSI model. This is the original TCP/IP model. You can see that still the transport goes to transport, network goes to internet, and then data link and physical still go to the link layer, and they're still mapping over the exact same way. They just divided it here into another layer, just so you can get a better understanding. But one of the things that you need to understand, all right, it's something called encapsulation and de-encapsulation, all right? Now, this image is not what have you. I have a nice little, well, before I even close this, I'll explain it and then I'll show you. When information flows down the OSI or down the TCP/IP, it's called encapsulation. Each layer puts its own PDU, right? Protocol Data Unit on there, okay? Which is called what? What's it called? What's the acronym? Don't stop pouring free beer. Now, obviously, that's not what it is. It's data, 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 okay? Segments, packets, frames, and bits. All right, that's what you need to know. Don't stop pouring free beer just lets you try to remember it. It's a mnemonic device. Okay, but it's the same thing here. So this data, data, data here translates to data, segments, okay, packets, frame, and bits. So that's what this deal is. The same exact thing. Nothing has changed. Okay, it's just now 5 layers. So that encapsulation, when it goes into the other one, we're talking about de-encapsulation. That's taking things out. It starts taking things out. Okay, but these are things that you need to understand. Let me see here. And also these things I'm talking about now is what you need to pay attention to. This will be on your exam. All right, again, here's your layers, but here are the protocols that work on those layers. As you can see in the application layer, whereas the TCP altogether with the presentation and session, we have DNS, DHCP, HTTPS, we have JPEGs, NetBIOS, okay, secure protocols, SQL, all right, and then the transport layer, which maps over, we have the 2 main protocols. Network layer deals with ICMP, IPsec, obviously IPv4, we all know that. Data link, ARP, not in IPv6, ATM, CDP, PPPP, which are WAN protocols, MPLS, HDLC, and then the physical layer, Bluetooth, Ethernet, DSL, ISN, cabling, things of that nature. This is what you need to know. So this is the basics, really, all right, of what they, on their first chapter, of course, of the book that they talk about. But you'll get this documentation because I have a nice little thing here, okay, that explains that very well. All right, here is the OSI. Okay, here's the OSI model, and here is the definition of encapsulation. Here is your data, segments, packets, frames, and bits. These are your PDU units, okay, and it tells you what a PDU is already. Okay, so it gives you the definitions of what you need. So you'll have this information in your hands. This is what's important. Not the year that TCP came out, not who created TCP, but the new models, the layers of the models, what protocols work on the models, how information gets back and forth. That would be it. Okay? With that said, I'll see you in the next lecture.